So anyway, I just was hoping we could keep our head in the game here a little bit, and what I had on my mind for us to do was to review some low altitude chart symbology, and then just review some of
Okay.
the stuff that you and I have looked at, and maybe have a chance to discuss holding patterns a little more to see if you're clear on all that sort of stuff.
Okay.
And I think we'll be able to do it effectively. Let me just ask you before I start quizzing you or anything like that. How do you feel about chart symbols on the low altitude en route chart?
That's one thing I haven't really dived into.
Okay, no worries.
So
Well, we'll take.
I've glanced over it. I've read it once. I've looked at the keys once or twice, but I don't think I have them memorized. But I've got the basics though. Let's just say that.
Okay, great. Well, let's start with just some basic stuff. Like here, looking at, let's just pick any sort of airway. This is Victor 2587 here, and we see, I think you and I have done this once before, but let's just review a little bit. There's a 5,000 foot number here. Do you know what that is?
That's the MEA, right?
That is in fact the MEA. And then you'll be asked, what are you guaranteed when you're flying at the MEA?
Obstacle clearance, 1,000 feet over regular terrain, 2,000 over mountainous terrain, and navigation signals.
Excellent, good. And I always ask people, I've asked you this before, are you ever guaranteed communication?
Nope.
Good. All right. Underneath that, we see a little asterisk and a 4,000 foot symbol. I mean, a 4,000 foot number. Do you know what that is?
I don't.
That's only obstruction clearance, not nav signals. So we call that the MOCA, minimum obstruction clearance altitude.
Okay.
So if you had a problem, for example, you were picking up ice and the freezing level's at 5,000, you know that if you fly at 4,000, you're not going to hit anything.
Hello?
Yep. Did you get me? You
Yep.
still?
Lost your voice there for a second.
Okay.
Okay, yeah. So you said picking up ice, or for whatever reason I need to descend at 4,000, I won't hit anything, but no longer guaranteed the navigation signals.
Correct. Good. Now, if we look along this little segment of the airway, over here by Santee, you see it has this perpendicular end cap, but over here by Mover, it doesn't. That tells you that the MEA is about to change.
The little end cap is the MEA change.
That's correct. So when you see this little perpendicular end cap here, you know that the MEA is about to change to something else.
Okay.
Good. All right. And over here by Mover, the MEA does not change, so there's no little end cap.
Okay, got it.
Good. Underneath the Victor 2587 symbol, there's an 11. Do you know what that is?
Is that the distance for that segment?
It is. It's the distance, in this case, from Santee to Mover. Just that one little
Okay.
segment. The 5.6, the 56 in the square, is the actual total distance from Navade to Navade. So if you zoom out here, 56 represents the distance from the Salinas VOR to the Woodside VOR.
All the way up there. I see. Got it.
And if you add up all those little numbers, like the 13 and the 14 and the 11 and the 18, it should all equal 56.
Okay.
Good. Now, there's one other number I wanted to look at. There's this 29 that looks like it's circled in a D, in a delta. And that's the DME distance from the Navade that's opposite the arrowhead, basically. So that's the distance to Salinas from there.
Okay. Yeah, that makes sense.
Right. And again, if you add up 29 and 27, you also get the 56.
Yep. Okay.
Good. Now, if we were only using VORs and you were navigating this airway, Victor 25, do you know when you would change over to the next VOR in front of you?
Okay, so if there's no, or navigating on this, we're going to change at Santee, but if there's no bend or no, I think there's like a little zigzag or I think you call it the half swastika, that's right.
Yeah, that's right. The half swastika.
We change it at the half swastika or at the halfway point or at a bend.
That's correct. Yeah, and let me find one of those little half swastika symbols just so we know we're both talking about the same thing. Let me know if you see one. Where would there
Okay.
be one? Oh well, we'll come across it. When I see it, I'll point it out to
Okay.
you. Um,
All right.
Good. But the other thing I want to point out is sometimes at intersections there's these little flags. Like right here by Cathay, there's this little flag with an
Back.
X. Yeah. Oh, there's a half swastika right here below that. The 44.
Oh
And
yeah, there it is.
there it is. Yeah. Okay. So
Cool.
yeah, that's a changeover point, and it also tells you obviously the 44 and the 22 is the distance to whatever nav aid. Like 44 to the one up to the right, 22 to the one down to the left.
Okay.
Good. All right. And so if you ever see one of these little flags, you'll see, I think, three different kinds, one with an X, one with an R, and one with an A, maybe. I have to check on the A. But the X is a crossing altitude, meaning it's a minimum crossing altitude. So that means you have to cross that intersection. In this case, if you're on Victor 107 and you're headed to the northwest, you have to be at 7,000 feet by the time you cross that intersection.
But it's a minimum altitude. You can be higher if you need, right?
Correct. Yeah. What they're saying, though, is all the guarantees we gave you about the MEA will not be in effect unless you're at least at 7,000 feet when you cross that northwest bound.
Okay. So if we look at the legs north of where it says 5500 G261, are we going to see that the MEA is now 7,000?
Yeah. Yeah. Let's see. Where does it go? Let's see. It's it's up to the left. So you'd be moving this way. So you're on Victor 107.
Oh, I see.
See, it looks like it's funny because the MEA is 7,000 on either side, but they put the crossing altitude there because they're saying if you're any lower than 7, you're not going to pick up that cross radial. You're not going to see this intersection. You're not going to get those nav signals.
Oh, so I guess maybe they're saying that for people on Victor 111.
I think there's
Perhaps.
it's because of this note. It's definitely Victor 107. I mean, it says it right there, Victor 107.
Right.
Right? But they're saying if for some reason you are below the MEA, like you're at 6,000 feet because air traffic control just has you there and it's okay or whatever, you're going to need to be at least at 7 before you can receive Victor 111 as a cross radial.
Okay.
Or there's terrain, right? So let me show you the other kind of flag
So,
you see.
so is that a mandatory, or is that 7,000 a mandatory crossing then?
Yeah, absolutely. If ATC didn't give me a climb to 7,000 and I was approaching that intersection, I would query them. I would say, NorCal approach, 36 Echo has a 7,000 foot minimum crossing altitude at 12 o'clock. Please advise or whatever. I'd let them know.
Okay. Got it. Okay. So that's saying you have to be there.
Right. Now they can supersede that. They can say, oh, don't worry about that. We've got a minimum vectoring altitude. I have radar contact, maintain 6,000 and turn left heading 300 or whatever they do. But
Yeah.
they would have to assume control of your navigation because based on the information you've got, you have to be at 7,000 or you're going to hit a mountain or something, right?
Okay. Understood.
Good. And then over here is a minimum reception altitude. This is actually more what I was talking about, receiving the cross radial. If it has an R in it, then they're saying you will not receive this 219 cross radial unless you're at the minimum reception altitude of 7,000 feet.
Okay. So the X is mandatory. The R, is that mandatory as well, or do it's just a note saying that you're not going to receive that?
No, it's mandatory because all of
Well, I
this.
guess you're going to have to switch the nav aid to hit the new heading.
Yeah, and remember that all of this information is assuming you lost comm. Like you lost communications, so you are flying only published information. You would have to be at that altitude to receive that intersection. 9 times out of 10, air traffic control is already going to have you there. And on that 10th exception, air traffic control can take control of your navigation and say, oh, forget that. We got you, radar contact. Okay. We're going to vector you. But the published information here says that if I'm not at 7, I won't see that cross radial.
Okay.
And by the way, that's a published holding pattern right there. That's how they draw them. That's how they look. It's sort of a weak way to do it. They're tiny little symbols on there, but that's a published hold left-hand pattern at Eugen.
Okay.
All right. Good. All right. So what else have we got? Lots of flags here. If you look around, like tails, that's one that we're often at. Minimum reception altitude of 7,000. Pyrat out to the left, minimum reception altitude of 10,000. So those are pretty common. All right. So let's see. I think we talked about this on our walk out to the plane last time, but this large 3 with the superscript 2 next to it is called your minimum off-route altitude or your off-route obstruction clearance altitude, depending if you're using JEP or not. And those are different than the VFR altitudes in the sense that they give you 1,000 or 2,000 feet of terrain clearance. That's not telling you the highest obstacle is 3,200 feet. That's telling you that if you fly at 3,200 feet, you're at least 1,000 feet above the ground.
Okay.
All right. Good.
So if you're using RNAV, you would take those into consideration. Is that right?
Yeah, for sure. And exactly. That's exactly right. And that's a really great point because, back in the day before everybody was flying around with GPS, it was a big deal to go what we called IFR direct. Like if you said, oh, I'm going to just go direct IFR, you would assume responsibility for all the things we just described, terrain clearance, signal coverage, all of that falls on your lap. And if all you have in your airplane is VORs, then you have to know how far out the VOR signal goes, when do I change over? Basically, all bets are off if you're going direct, right?
I see, yeah.
But in the world we're moving into, everybody goes direct because everybody's navigating off satellites, right? Like everybody's using GPS.
Yeah.
So it's no longer such a weird thing to go IFR direct. However, these altitudes still apply.
Okay.
Okay, good. So that's the only thing about going direct anymore. You don't have to worry about VOR signals and all that, but you do have to make sure you're clear of terrain on your own.
All right, and that's the minimum.
Yeah, that's the minimum off-route altitude, the MORA or the OROCA, whatever, depending on which chart you're using.
Depending on the chart, okay.
Good. All right, let's see if there's anything else we want to hit right now. I guess just one minor thing is that whenever you see these open triangle symbols for intersections, like pretty much all of them are open triangles, that's technically the symbol for a non-compulsory reporting point. So technically all of these intersections are reporting points. They're just non-compulsory. So ATC can tell you report reaching DCOT or report reaching SONOL or report reaching something else. You don't have to report it unless they tell you, so it's non-compulsory, but they are reporting points that ATC can tell you to report.
Okay.
And the reason I point that out is there is one compulsory reporting point still left in our area. I'll show you what that looks like up by Mendocino. There it is. Notice
so that's the solid black ones, right?
Yeah, exactly. So notice Mendocino is solid black and filled in. That's a compulsory reporting point. Now here, just to make this a little more confusing, when I say compulsory reporting point, again, this is an archaic sort of system. Like if radar went down, if radar was lost, they would tell you resume normal position reporting, as if that's normal, but that's how they would say it to you.
I see.
Yeah, because they're still trying to figure out this old world coming into the new world. So if you were southbound toward the Bay Area and you were on Victor 27 here, and all of a sudden NorCal says to you, yeah, 26 Echo, we lost radar contact on you. I'm not sure what's going on out there. We're going to have to check the station. But in the meantime, I need you to resume normal position reporting. Then when you crossed Mendocino, you would have to give them an official position report. And I'll just give you a little assignment because I don't want to go off into the weeds here. So maybe just jot this down. Go to YouTube and search oceanic position reports. There's tons of jet pilots who love to post this stuff to YouTube, and every time they fly over the ocean, they make a position report in the form of what we used to say IPTA-10. So it's IPATEN. Your ID, your position, your altitude, the time. There's like a format to it. And if you just go to YouTube and search oceanic position reports, you'll hear a bunch of guys giving those in the exact format that ATC would want.
Okay, will do.
All right. Cool. Before we leave the chart, is there anything else you wanted to look at on here?
Let's see. No, I think that covers. I'm sure if I come across a symbol that I don't recognize. Okay, so yeah, what about these little water dropper looking things? So see where it says off of the Geter intersection, bottom center.
Let's see, bottom center.
Move your hand down. There's that intersection that's got all these airways.
Oh God, yeah, okay.
Converging.
Yep.
Off to the right at the 226. What's this 114.4 ILA 91? What's that thingy?
That's telling you that this cross radial is coming from the ILA VOR, which is 91 miles out that way on a frequency of 114.4.
Oh, okay.
Good.
Okay, so you can identify it.
Yeah, so you can identify this intersection via the cross radial. Now the minimum crossing altitude here, and I guess the MEA, that's not a reception altitude, but my guess is you'd have to be at 12,000 or so before you pick that up, but they don't put a flag there for reception, so who knows.
Okay.
All right, cool. Good. All right. Excellent. All right, so that's pretty good chart stuff for now. Why don't we look at some of the stuff you and I have worked on? Let me just get over to a different thing here. Let's see. So if you're on this airway, you're headed to the northwest. VOR number 1 shows that you're tracking the needle in the center, right? Looking at VOR number 2,
okay. Yep.
Have you crossed the station yet? Like, have you crossed
okay,
that
so that's
second...
showing the... Okay, so this station is, assuming the station is to our left, we've got a from indication, so I'd say no, we haven't.
Excellent. And what's one other way that you would know that you haven't, just for redundancy?
Okay, so my heading is, what is that, 1, 0, 2, 3, something like that?
Something like that, yeah.
Okay, so if I look at that on the VOR number 2, I could see that I'm heading towards that needle if I point my airplane that direction. If I look at my heading on VOR number 2.
Excellent. Good. So you're still headed toward it. And then I'll zoom out here to show you that that's in fact correct. So that's the circumstance right there.
Okay, got it.
And watch what happens when I fly that airplane up the airway. Watch the number 2 radio. This makes sense. It starts to come in. And now if you were looking at a checklist or something and you were distracted and you looked down immediately, you would know, wait a minute, I crossed that radial, because it's not same side safe anymore, and my heading is now going away from the needle. That means I crossed it.
Okay.
Okay, good. So that's same side safe, and that's redundancy there. Does that feel pretty solid? Do you want to do any more of those or any more work here with the VOR?
No, I think I feel pretty good about that one.
Okay, good. All right, so let's bounce over to holding patterns and see how that looks. How do you feel about holding pattern entries or holding patterns in general? This is like the edge of what we've tried to push towards so far.
Yeah, I think I've got it. It takes a lot of brain power still at this point, to, and time and brain power, but I think I've got the basics of it, so I think I could figure them out.
All right, so let's say you're flying along that airway that we just said, and ATC, so you know what I was going to tell you is that generally when they tell me they have holding instructions for me, I start to slow down, because my CFI Richard always used to tell me, make them push you into a hold, like ask them, like negotiate with them, say, can I reduce speed? Can I get delay vectors? Like, is there anything you can shove off onto them so that all the work's not on you,
Oh, I see.
But if you can't, whatever, they say negative, I need you to hold. We've got 4 aircraft going inbound. You're number 5. I have instructions advised, ready to copy. So you say, I'm ready to copy. They say, okay, 26 Echo, hold southwest of the VOR on the 210 degree radial. Maintain 7,000 and expect further clearance in 15 minutes.
15 minutes. Got it. So holding southwest of the VOR on the 210 degree radial, 7,000 feet. Expect further clearance in 15 minutes.
Correct.
All right. So then,
yeah.
So basically, assuming that I'll say it's 210 radial. So I would get the inbound course for that first, right?
That's
so it'd
correct.
Be 030. And then they didn't say left or right turns, so it would be right turns.
Good.
I put my thumb up here. I'd see that would lie in the direct area.
Okay, so but don't get confused. I think you might have the 030 might have screwed you up. So make sure that you're seeing it like this, that it's coming in on this radial like that. Right? So you are headed 030, but you're holding southwest of the station.
I want to make it. You're right. I got confused on that part. That's
okay.
Right.
So
okay.
now that I did that, what do you think?
So that being the case, it would be on the parallel entry side.
Excellent. Good. And hopefully you saw that kind of in 2 parts, that you saw this part like that, and you could kind of visually see it, say, oh yeah, I'm flying to the non-holding side, so clearly the easiest thing to do is cross the fix, turn left, go out for a minute, and then come back in. But you could also put your thumb over here, like you mentioned, and see that it's opposite your thumb on the top, which makes it a parallel entry.
Yep, okay.
Good. Okay, so now that we know it's a parallel entry, can you tell me the 5 T's for what we're going to do when we get there, and that's turn, time, twist, throttle, talk?
So I would turn to 210. Do we start the time on this, or you only time the yeah, you do it 1 minute, right? 1 minute outbound.
Yeah. Now
start a timer.
Yes. For the entry, you're gonna hit the timer. You're gonna go out for a minute. Once you're established in the hold, and we're gonna talk about this next, the outbound leg is yours to modify such that the inbound becomes 1 minute.
Right. Okay.
So.
All right. So I would start a timer for 1 minute. Turn time. Twist. I would twist probably to the inbound course, right?
Definitely. Yes. Absolutely. Every time. Good.
Okay. So that would be twist to 030.
Yep.
Turn time twist, throttle to holding speed, which
Good.
is, I don't know, like 90 or 100 knots, more or less?
Yeah. Yeah.
Okay. Throttle and then talk. So do you report when the first time you cross the fix, or when you're, I would assume you cross when you first cross. You tell them when you first cross the fix, right?
Yeah, there's some debate about it, but I do absolutely tell them right then and there. I don't want to forget about it, and I consider the entry that I'm in the hold. I'm entering the hold. I'm in the hold. I'm in the process of there. So yeah, when I would cross this fix, I would say NorCal approach 26 Echo, holding whatever fix this is, 7,000 feet, time now 1714 Zulu. So
okay, you put the time.
Yeah, it's a requirement. Time and altitude entering the hold.
Okay. Do you always have to do it in Zulu, or can you tell them local?
You can tell them local. I think I've done it either way, and NorCal or most ATC facilities are pretty good about it. And when you and I practice this, even in the simulated environment, I'm just going to have you do that every time. NorCal will just say Roger, or they'll say thank you. They just so your habit is always, when there's always 5 T's when you enter a hold.
Okay.
And let me see.
Okay.
Yeah, good. Let me see if I can create this now back in NavTrainer. We were headed west. Let's see, we were going right. Let's put you on VOR1. We were headed directly toward it. So it was like this. Let me see if I can show you what this would actually look like. Okay. All right, so that's a visual depiction of what we just drew on the heading indicator, right?
Mm-hmm.
Okay, so just to bounce back one more time, we're headed west here, right? And we were asked to hold southwest. So here over on this trainer, what I want you to notice is what happens, why we twist the inbound course. Okay, so you're flying toward this thing. You just copied your holding instructions. You're briefing the 5 T's. You're saying, okay, when I get there, it's a left turn to 210. And I am going to ask that you please just say left or right when you're briefing yourself, so it's a chance for you to catch any mistakes.
Got it.
Good. So just say, when I cross this, I'm going to go left to 210. I'm going to twist my inbound course of 030, throttle back to holding speed, turn time, twist. Sorry, start a timer for a minute, twist the inbound course, throttle back to holding speed, and report. So here it comes. Notice, watch the flag on the number 1 starts to flip. That's all you can see in the airplane. You're looking around. Okay, the needle starts to go wide. You're thinking, I'm not going to chase it. Boom, the flag flips. You're like a racehorse coming out of the gate. You make a left turn to 210. Okay, and you start, and then the airplane begins like sort of moving in that direction. You start a timer for 1 minute, and you twist the inbound course of 030. And now, remember we said you can always see yourself as flying the heading on the case. So if you look up at the top right VOR here, you should see yourself as pointed toward the bottom of the case on the left side.
Bottom of the case. So because we're flying 210, right?
Yep. And this is, yeah, good. So what you would see is, I wish I could annotate on this thing, but I can't. I could use my mouse. Yeah, you should see yourself as, I crossed the fix, if you can see my mouse. I turned left,
Yep.
so I'm over here on the left side, and now I'm coming down this way on the left side of the case with the two headed,
Oh, I see what you're saying. Yeah.
headed, right? And watch what happens now at the end of 1 minute. Oh, and by the way, you tell them 26 Echo holding at the VOR, 7,000 feet, time now, 908 local. And at the end of 1 minute, you're going to make a left turn now, back to 030 or some intercept angle. Like that. Boom, and now you kind of fly in that intercept. And once the thing comes in, now you're in the pattern.
Okay.
I don't know if that's helpful or confusing the way we're doing it here over the computer, but
No, I think I get it. What I'm trying to do is picture the angle for the parallel, how we got out, because we crossed the fix to enter, and then we immediately turned to the outbound course, right?
Yep. Yeah,
And then
yep, you did that. You got there, you turned left to go opposite my arrow here.
right, then when you do that, when you're paralleling, and then you fly out for 1 minute, and then you just kind of turn around. Basically, you're just trying to turn around after that 1 minute, intercept the inbound course, and that's pretty much it.
That's correct. And you want to know something cool about parallel entries that you might just plant in the back of your brain? It may or may not help you, so I'll just throw it out there. If it helps you, grab it. If not, I'll keep throwing it until you say that doesn't help me. Or you say, I got it. Here's something true. Here's something true about parallel entries. The first 2 turns are always opposite the direction of the pattern. And it's the only time that happens.
Okay, first 2 turns, opposite direction. Okay, so if it's a right-hand pattern, we're going to make first 2 turns to the left.
Right, and you can see this here visually. Like if you cross this fix, you have to turn left to parallel it, and then left again to intercept it, but now you're in a right-hand pattern.
I see.
Does that make sense?
Okay, yeah. My question was, once you fly outbound for 1 minute, yeah, how do you know how to intercept that guy again? But basically, you just do
Oh, I'm so glad you asked that. Can I?
intercepting.
Can
Is
I?
there like a rule of thumb?
Well, I'm so glad you asked that because that's what. Let me show you here. That's why you twist your inbound course, because if you see yourself as flying this way, you always turn toward the needle. So
Okay.
that's how you know. Once you twist the inbound course, all the visualizations about the pattern should make sense. If you didn't do that, there'd be some weird things. But because you twisted the inbound course and you know you're flying 210, it's always a turn toward the needle to get back in there. So like this, you'd come out and then you would turn left to some intercept, depending on how fast you were moving, like that. Boom. And you're in the pattern. So you're flying toward the needle. This might seem a little confusing right now, but I think the more we do these visualizations, the more they'll pay dividends. And I don't want to confuse you right now, but sorry, where'd that come from?
I can see what's happening. I think I just need to practice it.
Yeah.
I think it makes sense.
But there's definitely because for me there have definitely been times I've seen this 100 times over. Let me just go back to one where was the original situation. Let's see, we were headed west like this. This is like honestly happened to me. I mean, not so much anymore that everyone flies with moving maps, but imagine I was flying into a really stiff headwind right here, like really stiff headwind, like say 35 or 40 knots, right? And I didn't know that because I don't have a G1000. I'm not really keeping track of where the winds are. I'm just following the needle, right? And based on my entry, I look at this and I say, okay, when I get there, I'm going left to 210. I'm going to start a timer for a minute. I twist my inbound course to 030 and I report. I'm all ahead of the airplane. Everything's looking good, but I don't know about the wind. This visualization will save the day because this is what will happen. This is what happened to me, is you cross the fix. You come out of the gate like a racehorse, you turn to 210, and you twist your inbound course, but the wind pushes you back over the holding course like that.
Oh, yeah.
Now, I know immediately looking at this needle that something's wrong. I know I'm on the wrong side of the pattern because I could just see if I were inbound to that thing, I'm on the right side of the course, not the left side of the course. I'm on the wrong side of the pattern for a parallel entry. And if I make a left turn, if all Joe remembers is, well, Jason said there's 2 left turns in a holding pattern, and all of a sudden I start to turn left and I get blown downwind like this, now I'm really lost.
Oh, yeah.
You see what I'm saying?
Yeah.
So that needle visualization and seeing the needle visualization can, like, once you and I are finished, like, ingraining this in your vision, you will catch things like that simply just by looking at it the same way you catch same side safe.
Okay.
All right, cool. Let's do another one of those entries because I think that I just want to make sure you got that. All right, so let's say we're we're still headed west, unfortunately, because that's the only picture I have. But I'll give you another one here. All right, let's say ATC comes on and says, what's the plane you normally fly? 410 Bravo Sierra. I have holding instructions. Advise, ready to copy.
Okay, ready to copy.
All right, 410 Bravo Sierra. I need you to hold west of the ABC VOR on the 300 degree radial. Maintain 7,000 feet and expect further clearance at 2115 Zulu.
Okay, so 410 Bravo Sierra is to hold west of the ABC VOR on the 300 radial, 7,000 feet. Expect for the clearance at 2115 Zulu.
410 Bravo Sierra, readback is correct.
Okay, so then I look up here, 300 radial. Okay, so first my inbound course is going to be 120, I believe. 300 radial is up here. Where am I looking? Yeah, that's correct. And you didn't say anything about left turns. So That is going to be in the teardrop.
You got it. Awesome. All right, so let me just
Okay.
draw it, make sure that you saw it like I saw it. So it goes like that. And then you said we were going to get there and make right turns, which was correct. So you saw that correctly as a teardrop entry.
Cool. All right.
Do you know the LARS acronym? Have you heard that?
Yeah, I forgot what it stands for.
Okay, this is like, because theoretically now you're gonna come like this and cross this fix, and you have to know what heading is a perfect teardrop, right? So the LARS acronym tells you if it's a left-hand pattern, you're going to add, and if it's a right-hand pattern, you're going to subtract 30 degrees from the outbound. So let's just run
Okay.
that.
Yeah. Okay, so if this is a right-hand pattern, so I would subtract 30 degrees from 300, which would be 270. So basically, after I cross the fix, I want to make my heading 270 for 1 minute,
Correct.
and then a right turn at standard rate.
Correct. Yep. And so and your job now would be to get just one step ahead of the airplane. So just, what am I going to do when I get to that fix? I'm going to not turn in this case because I'm already headed 270. I'm going to start a timer for 1 minute, twist my inbound course always of 120, slow down to holding speed, and report time and altitude entering hold.
Okay.
Sweet. All right. I think you've got the entries, and I think the only thing that you did on the first one, which seems like you've corrected, and it's probably the most common mistake I see, is you looked at the inbound. Just make sure you stay on the side of the fix that I've told you to be on, even though you're pointed to the inbound.
Yeah, and okay, yeah, that makes sense.
Okay.
They give it to you. That's actually a lot easier. They just give you that. You could look at it right away and probably figure it out in your head once you got this down really good.
You absolutely can, and my hope for you at the end of the day is that you don't even put your thumb up there, but that in your mind you do a double check. So I just want your brain to have two ways to see it, so you can guess at it first and then sort of confirm it in your mind. And
Confirm it.
yeah, and if you can see your thumb up there without holding your thumb up there, that's fine, but it's still redundant because those are two sort of different things that are proving what you're thinking is true.
Got it.
We didn't actually do it in that case, but I mean, I could do it real quick. So just, what did we say? So yeah, the process would be guess at it first. You guessed at it and you said teardrop. Second step would be put your thumb up there and verify teardrop. Remember we said if it's right above your thumb, it's always teardrop. So this is the teardrop, this is the parallel, and this is the direct for a right-hand pattern.
Okay, got it.
Good. All right. What was I just going to say? So teardrop, parallel, and direct. Okay, anyway. All right, do you want to do one more of those? Or are you feeling pretty good on that?
Yeah, you know what? I think repetition is key here. So
okay,
let me try one more.
Sure. Let me see if I can make it a little harder even. Okay, so, all right. All right, 410 Bravo Sierra. I have holding instructions. Advise ready to copy.
Okay, 410 Bravo Sierra, ready to copy.
All right, 410 Bravo Sierra. I need you to hold southwest of the ABC VOR on the 210 degree radial. Make left turns, please. Maintain 7,000 and expect further clearance at 2130 Zulu.
Okay, 410 Bravo Sierra, so hold southwest of the ABC VOR on the 210 degree radial, left turns 7,000 feet. Expect further clearance at 2130 Zulu.
And 410 Bravo Sierra, the readback is correct.
Okay, so now 210, the reciprocal of that is 030. I believe, yeah. Just going to put that in my notes. So I'll write that down. So 210 is that direction up there. We're making left turns. So that one seems like it's kind of on the line. So the rule, the thumb is supposed to put that line. Is it 20 degrees?
Yeah, well, you subtract, basically 20 degrees. Yeah, it's 70, depending how you think about it. But yeah, 20, however you're looking at it.
Or 30 then, it would be 30, 70, 30, or what's the split there?
Well, because it's off 90, so it's a 70-degree line instead of a 90-degree line. So 20 was a correct answer, depending on how you look at it. But yeah, like the line, if in a left, would be like this. And remember, if it's right on the line, it probably doesn't matter which one you do. It's sort of your choice, honestly. Like if it's a matter of 3 degrees this way or that, these are just recommended entries really anyway. It's not like, as long as you're in the protected airspace, the mission's accomplished, So just keep in mind, if it's right on the line, don't sweat it too much. Do either thing.
Okay. So then I would do a teardrop then in this guy.
Excellent.
Sorry. Yeah. Teardrop.
Good. And then and I just want to make sure too that you're guessing first and using thumb second. So you would see it like this. You would see the left-hand turn like that. And since you're coming up from the bottom, it makes sense that you would do a teardrop.
Okay, I see what you're saying. Just visualize a pattern on the instrument and then draw the lines with a 20-degree offset.
Yeah, and then as a second thing, see your thumb up there, see it, and go, yes, that's a teardrop.
Okay.
And those are sort of the two, that's the redundant part of it, right?
Yeah, I see.
Okay, good. And so let's just do the 5 T's for when you get there.
Okay, so when I reach the ABCBOR, I will turn. So this is a teardrop. I'm going to turn 210. So I will turn to 240.
Good. Left or right?
I would turn left to 240, start a timer for 1 minute. Twist my inbound course of 030. Throttle down to holding speed and report entering the hold to ATC.
Excellent. That's great. That's exactly right.
Okay.
All right. Excellent. I guess the last thing I wanted to kind of push into is now you're established in the pattern. There's just a couple rules of thumb for being in the pattern. One is if you figure out on your inbound course, let's say you intercept a pattern and you're flying in and you realize I need a 10-degree wind correction to hold this needle. So I'm actually flying like this, right? I've got some kind of wind out of the northwest. I need a 10-degree correction. The rule of thumb says you will triple that correction on the outbound leg. So if it's 10
direction, I see.
Yeah, if it's 10 degrees when you're inbound, you cross the fix, you turn left, in a normal world you'd be going to 210, but you're actually going to stop at 240 because you're tripling that correction. And the pattern won't really look like a racetrack in real life, it'll look like a teardrop, but that's because when you make this next turn, the wind is going to be at your back and you'll pick up your ground speed.
Oh, I see. Because it's a standard rate turn on both sides, so yeah, the wind's going to mess you up.
Very good, man. That's exactly right. That's exactly right, because you have to account for both the outbound leg and both turns, and that's why you triple it.
Okay.
Sweet. All right. Yeah, that's really good, man. So just sort of some golden rules about holding. We always determine the entry using the outbound heading. When we cross the fix, we always twist the inbound course. And when we find a wind correction angle on our inbound, we triple it on the outbound.
Okay.
Golden rules of holding. Perfect.
Triple outbound.
Yep. And then to kind of just wrap that up, I pulled up this from the AIM. Just want to see if there was anything. Good. And see here, it's recommended. Sorry, the last sentence of the AIM here is recommended by the FAA. My instrument examiner was a guy named Lou Fields. He was an old Navy pilot, and he used to teach on carriers. He was like this crotchety old dude, and I was acing my check ride. I was doing really, really well until the last hold he gave me, and I almost turned the wrong direction. And he held the yoke. he reached up and he
didn't
grabbed.
want you to fail.
Yeah, he wouldn't let me fail. He knew I needed. He knew I was good enough to get the rating, and he was a nice guy, and it had been a great check ride. But when I went to make the turn to the wrong direction, I couldn't move the yoke, and I looked over, and here's this like 85-year-old dude just holding it, and then I got it. I like right away. I was like, oh man, I'm turning the wrong way. So when in the debriefing, he said, Jason, he's like, listen, all these entries are fine and dandy. He said, but they're recommended by the FAA. And if you're confused in a light airplane, you're not flying an F-16. If you're confused in a light airplane, when you get to the fix, just turn outbound. It doesn't matter which way you go. Just turn outbound, go for a minute, turn around, and come inbound. I just think sometimes people get so confused about what entry is proper, or like you said, is it right on the line this way or that way? The bottom line is you have 8 miles of protected airspace on the holding side, and you have 4 miles of protected airspace on the non-holding side. If you're going 90 knots, that's 1.5 miles a minute. You would have to cross the fix and fall asleep for almost 3 minutes before you were in danger.
Got it. Okay. Yeah, that makes sense. So as long as you just get back, if you can't figure it out.
Yep.
Or if you're behind for something.
Yep. All right, man. Well, that's kind of what I wanted to get through. Is there anything else you wanted to talk about today before?
No. I think that covers it. I can practice this stuff here some more. I've gotten through all the methods and systems videos. So I guess I'll just go ahead and brush up on this stuff. How important is ADF? That was in one of your videos, and that's how much I need to drill into that.
What's interesting about ADF is, as far as the ADF goes, it has zero importance in today's world. But here's the irony: when Garmin built the G1000, they give you these things called bearing pointers, which can point at anything. They can point at a GPS waypoint, they can point at a VOR, and all they do is point at it. And I almost doubled over laughing when I realized all my students who are saying, thank God I don't have to learn ADF anymore. I'm thinking, well, wait a minute. Navigating on a bearing pointer is the exact same visualization. So if you learn what I'm teaching you in those methods and systems videos, you are going to be one of the 1%ers out there that can actually navigate on a Garmin bearing pointer in the G1000, which I think is a good skill. There'll be a number of times when you and I are in the sim where you do that just temporarily, maybe while you're intercepting an ILS course or something. And most people don't have those skills, but yes, they're totally relevant for GPS bearing pointers. So
okay, that makes sense.
Yeah, so just learn what I'm saying there, because
you can make a GPS. You can make a GPS bearing pretty much off of anything, like off of a intersection, VOR, airport, or whatever.
Yeah, absolutely. And most people don't know how to do it, so they just use the bearing pointers to point randomly, and then they see, or they just use it for cross radials or whatever. But you can navigate very, very precisely on a bearing pointer, because it's like an ADF that works perfectly, because it's pointed at a GPS signal and it's digital. But it's the same exact, it's everything I'm telling you. Parallel the course, note the needle deflection, turn twice the needle amount or whatever. And I mean, all those ADF visualizations are inside Garmin now and these bearing pointers. So
okay, cool. So I'll practice that some more.
Great. Yeah, that's a good one, and we'll get to that when we get to the sim.